Okay, um, I'm having a lot of issues with recording, and I've had so many audio mess ups that I've had to re-record this. This is probably my fourth time recording the same video, and you can see I've been every time I record it, I add a little bit more, but hopefully it was the last time because I'm using different software. So, um, Riemann trapezoid rule. This is Delta 5.6. This is review. We did this in Unit 1. What is it all about? So Riemann sums are rectangles. If you recall, that is this picture on the left here. We have three different types. We have right Riemann sum, mid Riemann sum, and left Riemann sum. And the purpose, again, is to approximate an integral, approximate the area under the curve. It's not exact. It's an estimate. And again, you have three different types. The right intersects on the right side of the rectangle, mid is in the middle, and left is on the left side. And how do you do it? Really, you're finding the area of these rectangles individually, and then you add them together. That's how you do Riemann sums. Then you have trapezoid rule. So trapezoid, very very similar to Riemann sum. The only difference is that it's not rectangles anymore; it's trapezoids. And to find the areas of those trapezoids, you use this special formula: 1/2 b1 plus b2 times h, where b1 and b2 weirdly are kind of the heights, and the h is the base, because that trapezoid is kind of on its side. Okay, so if you know the formula and you know how to identify the values from here, you're good to go. And we'll do the practice problems in a moment. Okay. Then we have, this is another common question that the AP test likes to answer. A typical question might look like this. A typical question might ask you, use the trapezoid method, or use a right Riemann sum, or use a left Riemann sum to find a certain value, or to estimate a certain quantity given a table. That might be A, and B might be, okay, well, was that Riemann sum that you found, was that an overestimate or underestimate? And this is where this is helpful. You can also do this by drawing. Um, if that function is increasing, like this one here, and it is a left Riemann sum, that will be an underestimate. You see here, like the gaps that you have, that's an underestimate. Whereas if it's decreasing, like this one down here, see how it's decreasing, but it's a left Riemann sum, it'll be an overestimate. Similarly, for a right Riemann sum, uh, it's an overestimate if it's increasing like this here, right? But it's an underestimate if it's decreasing like this one here. Okay. So usually you can just get this by drawing it. You can figure that out. If you don't necessarily need to memorize it, but you need to understand what it's talking about. It'll otherwise say over approximation or under approximation. Okay. Um, Trapezoid method. It also might ask you this for trapezoid method. It's definitely rarer, but it can still happen. If it's concave down, right? See right here, CC down, that is an under approximation, right? And if it's CC up, it's an over approximation. Okay, so good to know. All right, now for the practice problems. Okay, again, I'm re-recording this a third time for this section. Never again, but I got it down now. We figured it out. Um, all right, practice problems. Riemann sums, practice problems, very classic, both AP multiple choice and FRQ kind of problems. Let's do it. So first one, very straightforward. We are using a Riemann sum to approximate the integral using three subintervals as indicated. So um, really, I think the most important part here is that the x is referring to, like, these are x values, and the f, whatever the output is the y. Um, that's really important. It might not say x and f of x, it might say t and f of t, but just know that this is the output, and I know that's the output because it's saying that here, right? This is what I'm taking the Riemann sum of, right? That's what's going in to my Riemann sum, okay? Um, and then three subintervals, it's good to label those. So we can see here we have from 0 to 1, from 1 to 4, and from 4 to 8, and those widths are 1, 3, and 4, right? That's just the distance between those numbers. Also really helpful is to kind of, maybe if you're like still stuck, is like sketch it, right? So we have 0, 0, 18 is maybe up here, then 1, 16 should be here, and 4 and 2 is here, and 8 and 22 is like way up here, right? And this is just, this isn't like accurate, this is just like to sort of show you what's going on. So a left Riemann sum would be up, over, down, and then like that. Okay, so these are our three rectangles. That's what we're finding the area of. Do you need to draw that every time? No. Is it helpful? when you're reviewing and to understand what you're doing. And if you're second guessing yourself, yes, please do it. Okay, there's no shame in it. Always do what you need to do to get the points. Okay. So if you think about the areas of these rectangles, let's do it intuitively, right? The height of this is the 18, left-handed, right? The height of this one is 16, this one. The height of this one is 2, right? We're not using the 22 because that would be the right-handed one. There will always be one that you're not going to use, right? If you're using left-handed or right-handed, you'll be missing either the far left one or the far right one, right? And then from that point, you're just multiplying, right? So we have 18 times 1 plus 16 times 3 plus 2 times 4. And that all together, let's see if I can do this. It's 48, 56, 66, 74. 74 would be your answer. Okay? Right? Makes sense? Next one is trapezoidal rule. So we have selected values from below. We're doing a trapezoidal approximation with 5 subintervals. Okay? So you can do a similar thing where you draw it out. This one's a little bit different because it's a trapezoid rule. Um, we have our intervals. Oh, I think it's always just good habit to mark the intervals just so you don't make mistakes. I think that's like a common place where people do make mistakes, little things that they just don't get the interval width right. That's 3, that's 2, that's 3, that's 3, that's 1. All right, I've got my 5 intervals. It makes sense. I should get 5 of each of these. All right, so if you think visually what's going on here, well, if I'll draw part of this just to get you started. 3, 12 might be here. 6, 6 might be here. 8, 2 might be here. What's going on is instead of like this when we're making rectangles, you are connecting these dots and making shapes in that way, like this, right? So for this first trapezoid here, we have a height. This height is 12. This is 6, and then this is 3. So remember, you just need to know the formula, which we talked about above, 1 half b1 plus b2 times h. That's b1, that's b2, that's h. So just plug it in. It's 1 half 12 plus 6 times 3. That is trapezoid 1, right? It's the base 1 plus base 2 times a half, right? Times the width, which is 3. Okay? And then you just repeat that. So then it'll be 1 half 6 plus 2 times 2 plus 1 half 2 plus 14 times 3 plus 1 half 14 plus 26 times 3 plus 1 half 26 plus 28 times 1. Okay, so again, it's just 1 half. These are my bases. That's my width, or my quote-unquote height, right? So these are each individual trapezoids. Then you add them together. I'm going to use a calculator. So we've got, that's 27. I can see that's 27. That's 27 right here. That's 8. That is 6. That's 8. That's 24. This one is, that's what, 30, 40, 20, 60. This one's 54, I believe. Yep, 54 to over 2, 27. 27. And so you just add these numbers up. These are my 5 trapezoids, 5 areas. 27 plus 27, that's 54. Plus the 24, plus the 60, plus the 8. 146 is what I got. Okay. Not too bad, right? But very much on the AP test, and very much questions that you should get. You should not be missing these questions because you can get them. You can do them, right? The functions f and g are continuous and differentiable with f of x equals g prime of x. Selected values for f of g are shown below. If the if the integral from 2 to 16 of f of x is 4, then what's the value of g of 16? This is a really classic AP question. Stuff that you'll definitely see stuff like this on the test where You know it, but it's just asking something in a little bit of a weird way. Um, Basically, this is applying fundamental theorem of calculus part 1. So if you recall part 1, no, actually part 2 rather. It's you recall in part 2. So we have a definite integral, and the application of the definite integral is the antiderivative of b minus antiderivative of a of f at a, right? So here, if I'm gonna evaluate this definite integral, right? If I'm evaluating this, um, I'm going to take the antiderivative of that and evaluate it at 16 and 2 and subtract the 2, right? And that's how I'm going to get this, you can imagine. The thing is, I know, you might say, okay, well, what's the antiderivative of fx? I don't know what that is. Well, I'm told here that fx is the derivative of g of x. So in a way, I can just kind of scratch that out and just put g prime of x, because that's what that's saying, right? You don't actually do that, but like that is what it's saying. I'm just showing that so you understand, right? So now when we take the antiderivative of g prime of x, you just get g of x. So really what this is saying is g of x from 2 to 16 is 4, right? So we're going to do g of 16 minus g of 2 equals 4. And I know, look from here at the table, that g of 2 is negative 2. So really what I have is g of 16 plus 2, right, because it's double negative, equals 4. My mistake, guys. Not here. It's right here. Negative 1 plus 1. My bad. G of 2 is 1. Sorry. I jumped ahead there. So g of 16 equals 3. That is your answer. Okay, so you're applying fundamental theorem of calculus. You're not formally taking the antiderivative. You're symbolically doing it and then using the table to find the answer. Okay. This one is a Riemann sum, but to find the average value. Okay, so this is what we did last unit, find the average value, which remember is 1 over b minus a. So I can just go ahead and write that. I want from 5 to 15, so it's going to be 1 over 10 integral 5 to 15 of f of x dx, of g of x dx rather, g of x dx. And remember that you're not integrating in the way that you imagine of taking the antiderivative. You are using a Riemann sum. This is a Riemann sum that we're using to approximate that. Okay, so we are doing a right Riemann sum of g of x, and well, the average value of g of x. So I have no business with f of x. F of x doesn't apply to this problem. I just am using g of x, so you don't need to worry about f of x here, right? If it said find the average value of f of x, I'd be concerned about f of x, right? If it says find the average of g of x, I'm concerned about g of x, right? So you don't feel like you need to use everything that a problem gives you. So I'm using the same way I did it up here, right? So I have my intervals from here to here, that's 1. From here to here, that's 5. From here to here, that's 4. Um, and then I'm doing g, and then on the right, good to underline these things, so that means I want all the right values, 8, negative 6, and 2. So it's going to be negative 8 times 1, plus negative 6 times 5, plus 2 times 4. These will cancel because they're both, that's negative 8, that's 8, so it just leaves me with negative 30. And then I've got to do 1 over 10 times negative 30, so it is negative 3 is my answer. That's the average value. All right, third time's a charm. Go ahead and do delta 5.6.